Okay, so here we have one with one linear factor right there, and then we have a quadratic factor over here. Okay, so I'm going to recopy the expression. You know, and you do a few of these and it'll get a little easier. It's kind of a lot of writing for them, but I think they're fun. It's kind of like a game. You're like, ooh, what kind of games is she playing? Okay, anyway, so we only have two factors, x plus 1, that's a 3, sorry, x plus 3, plus, and then we have this other one that doesn't factor. If it factored, we would have factored it. I should have mentioned that's not factoring. So it's irreducible. So x squared plus x plus 2. Now, what will we put in the numerator? Well, for the first numerator, I'm just going to put a because its denominator is a linear factor. So your numerator has to have a degree less than the denominator. But the other numerator, I'm going to have bx plus c because that will be a linear factor. Now, in the end, it might not be linear, like b might be equal to 0, but we don't know. So you have to set it up that way to see. You know? Okay. So I'll see if I can shorten the writing a little bit here. We're going to take the numerator, and we know we're going to get a common denominator. So it's going to be a times that x squared plus x plus 2 plus, and then it's going to be bx plus c times x plus 3. So if you want to see it, you know, I'm multiplying by x squared plus x plus 2 in both the numerator and denominator. I wasn't going to write all this out, but that's what you're doing. And then over here, you're multiplying by the x plus 3 to get the common denominator. Okay, anyway. All right, so now we're going to go ahead and do the distributing. I have to scroll up a little bit. We do have to remember that form that we had. I should write it like at the bottom, but I don't know how much room this is going to take. Okay, so ax squared plus ax plus 2a. So we're distributing this a in. Now I'm going to have to FOIL that out, the bx plus c times x plus 3. So I'm going to get bx squared plus 3bx plus cx plus 3c. So we got a whole lot of terms there. I don't know how many. 7? Okay. But now comes the matching game. So you have 8x squared. That has to equal the total of ax squared plus bx squared. I don't have any more x squareds. Okay. Then 12x has to equal ax plus 3bx, so any term that has an x, just x in it, plus cx. Okay, those were all of those. And then finally, the constant, negative 20, has to equal 2a plus 3c. Okay. All right, now that's great. So we're going to go back here, and we don't need the x squared, so we can say 8 is equal to a plus b. And then in the orange equation, we're going to say 12 is equal to a plus 3b plus c. And then the other one, we're not doing anything with that right now, but 2a plus 3c. Okay. So how are we going to solve this? You have 3 variables, a, b, and c. You have 3 equations. So it is solvable. What would I like to do? Maybe I want to substitute for a. So I'm going to say 8. Now, I wish I would have done it in green. I'm going to say 8 minus b is equal to a. Yeah, I don't like that already. That's okay. All right. I can substitute that in for a right here. Maybe I don't want to do that. Maybe I want to substitute it in for a right here. Okay. So I'm trying to look ahead to see what's going to happen here. All right. If I do that, I get 12 equals, and then this is going to be 8 minus b plus 3b plus c. Okay, now go ahead and subtract 8 from both sides. Combine your b terms. Okay, so now I have 2b plus c. Yeah, well, I can substitute for a with the green equation, and I can substitute for c if I make this, oops, trying to keep it color coordinated. If I make this 4 minus 2b equals c, there's other ways you could solve this system. You could put it in a matrix. There's other ways to do it. I was trying to look for the easiest way. But I'm going to substitute the orange part for c. So then I'm going to get negative 20 equals 2 times that 8 minus b plus 3 times the orange part for c, right? This part right here. 4 minus 2b. I was looking for the easiest way because eventually I've got to get it to one variable, one equation. But, you know, maybe you wanted to solve for b or something else. You just have to work it out till you get, you know, to get that all in terms of one variable. And it looks like I got it in terms of b. So 16 minus 2b plus 12 minus 6b. And what does that turn out to be? Negative 20 equals 28 minus 8b. And then I get negative 48 equals negative 8b, or b equals 6. Yay! I got an answer. Okay, so we know b is equal to 6. Then that makes it easier to find a, because 8 minus 6 is a. So we know 2 is a. And then we'll have to find c. You can just plug it in right here, the 6. So you have 4 minus 2 times 6 equals c. So what's that? 12, negative 8 equals c. Okay, we have a, b, and c. Now I have to remember what the original setup was. So it was a over x plus 3 plus, and then it was, not that. It was bx plus c over whatever that quadratic was. What was it? X squared plus x plus 2. Sorry. Okay, so the partial fraction decomposition is going to be, my a was 2, my b was 6, not plus, minus 8 for c. And that would be the partial fraction decomposition. You could check it by getting a common denominator and seeing if you get the right numerator. I wasn't going to do that. This video is pretty long.